Hello, welcome to day 14. Well, I'm just gonna say day 14 since I was supposed to do a problem yesterday, but we'll just call it day 14. Yeah, we're doing Leetcode 75. This is day 14, like I said. This is single number, which is 136. So we're given a non-empty array of integers, nums, and every element appears twice except for one. So we have to find a single one. And you have to implement a solution with linear runtime complexity. And you have to use only constant extra space. So we can only have a point or like a variable essentially we can like store another list. And we have to return a single value. So we see a list of 221. Their single value there is just 1. We have 4, 1, 2, 1, 2. The single value is 4, and just 1 here. And we said that each element in the array appears twice except for one element, which just appears once. And this is pretty interesting property. Well, like we're gonna use like kind of like I think it's like a intersection between math and career science kind of property here. It's pretty interesting. So we're gonna use something called to solve this problem, right? So essentially, you have to narrow. So we can only store a variable, and we have to be able to get rid of all of the duplicates and get only a single value out of the entire list, right? So right now we can say our result is equal to 0, which is just equal to if we do example 1, this is equal to 2 right now. So what we can do is we can go through the rest of the list and we try to find out which one is the duplicate and try to get the single value out, right? And the way we can do that is using something called a XOR, which is an exclusive OR, which means that anytime you do, and the notation is this caret operator, I believe it's called. So the way that you can apply a XOR operation is that you had so we'll do this in binary because it makes it easier to visualize things. So if you had like one XOR with 1, that'll be 0. I should probably go over what this actually means. So yeah. So 1 XOR, so basically when you have two values and you apply XOR to them, right? Only the opposites make 1. Okay, so that means that if you did XOR with 0 and 1, that this would be equal to 1. If you did it flipped, it would be equal to 1. If you do it with 0, that'll be equal to 0. So it has to be one or the other, but not both, essentially. And that is how you get your zeros and ones. So if we apply this concept with actual values like integers, because those can be represented in binary. These are all base 10, but they can be in base 2. So they could just be translated to base 2. So we said for let's just do example 1, right? So we have so we represent this in binary. That's 1 0. So this is base 2 of 10 is equal to 2, right? So that's just 1 0. I'll write it like as maybe a better symbol. That's a negation. Okay. We can do this to represent the places. So that's 1 0. So that if like in binary placement, it's right to left, so that would be 1 and 2. So and then if we had say that so that's element 1, right? And then we have element 2, which is also the same thing, right? So if we applied XOR to both of these, we're gonna get 0 out of them because in the same place they're both equal in the same place. So the resulting value of like 1 XOR, because it's in each single place too, right? It's like if you think about it like a column, it goes through that entire column when you apply these two. So that'll be equal to 0, right? And then say you applied XOR, so it's right now it's 0 0, right? You apply XOR with 0 1. So 0 0 is gonna be 0, but 0 1 is gonna be 1. So that's the output we're gonna get. It's gonna be that's how we're going to get the single value out. We're gonna because when we apply XOR across all of these like duplicate values, all the elements that appear twice, we're going to be able to narrow it down to where it is all zeros, and then when we do apply the final XOR onto the single value, it's just going to give us that. So like technically it can get more complicated, right, depending on which place it is, but no matter how you apply it, no matter what, it's not placement dependent, which is pretty interesting. So like say we had 4 here, but then it's like lined up in a way that doesn't look like it's appearing twice at first. It's when you apply XOR that many times, it will always fall back to 4, which is pretty interesting. We can write down the solution, and I can go over that second example as well. So right now the result is equal to like nums of 0. So we can iterate through the rest of the array again. So it's 1 to the length of nums, and then we'll say that res is equal to like res XOR with nums of I, and then afterwards we can just return res, I believe. Yeah. So that would be the solution for that. It's pretty like simple solution, but at the same time it's pretty interesting how like that mathematical concept can work out. So right now we have 1 0 0, which is 4, right? And then we apply that on 1. So right now our result is going to be equal to 1 0 1, which is equal to like 5. Then we do 1 0 1 onto let's say 2 1 2, right? It's 5. I guess I could just keep doing it binary. So the result of that will be equal to 1 1 1. So that's just like what, 6? Oh, sorry, 7. That's 7. And then we'll do the same thing again, 1 1 1, and then we'll do onto 2. So, or sorry, onto 1 1. So it'll keep cutting it out. Like it'll keep cutting out all those duplicate values out. So that'll be 1 1 0. We're on 6, and then we'll finally do 1 1 1, and we'll do that on 0 1 0. The result is equal to 1 0 1. 0 actually, so 6, and that'll be equal to 4. So that's how we get our single value out if we just apply these operations of these XOR operations, right? So yeah, pretty interesting problem, and that's how you solve single number.